Hello, hi my dear students. Today we are going to discuss solid state chapter in that defects in solids. Okay. That is, defects in solid means some irregularities in the arrangement of atoms or molecules in a crystal lattice. In a crystal lattice, the atoms will be arranged in an order, right? In any of the order has changed in their arrangement, such type of irregularities are called defects. So the defects in solids is an important topic. Its classification we can look. So it is mainly classified as two. Three you can denote, but mainly you have to study one in detail. Okay, that is, it can be of line defect. Three classification we can make defects in solid. First one is line defect, then we have point defect, then we have plane defect. Okay. First of all, what is a point defect means? In the crystal lattice, in any one point it is displaced or not arranged properly at a particular point only, then it is called point defect. If on the full row of a crystal lattice is not properly arranged, then it is known as line defect. In the whole plane of the crystal lattice, if it is not arranged properly, then it is plane defect. Clear? That's all. Okay, here we have to study about point defect. Point defect can be classified as again three. Fine, three. That is, one, it is stoichiometric defect. Stoichiometric defect, then non-stoichiometric defect, non-stoichiometric, then last one we have impurity defect. Impurity. Okay. So here first we will discuss about stoichiometric defect. What does stoichiometric defect mean? Stoichiometry means according to molecular formula of any compound, there should be a ratio of cation and anion. It should not be changed even some defect occurs. That is, it should not affect the stoichiometry of the compound. Such defects are called stoichiometric defects. Okay. In that again, it is classified as, you can see stoichiometric defects in non-ionic crystals and also in ionic crystals. Okay. Non-ionic crystals and ionic crystals, you can see the stoichiometric defects. In non-ionic crystals, you can see two types, that it is vacancy defect and interstitial defect. Interstitial defect. These are the two non-ionic crystal defects. Okay. So what is vacancy defect and interstitial defects? First we will discuss. So here, this is a crystal lattice where these atoms are arranged like this. At a particular arrangement, it will have the crystal lattice. Okay. And vacancy defect means at a particular position if some atom or molecule is absent, it is not present. So a vacancy has formed here. So such type of defects are called what? Vacancy defect. Okay. That is easy, right? Then what is interstitial defect? First of all, you should know what is interstitial site means. This is crystal lattice. This arranged atoms and the place where the atoms are not, this between gaps, right? Void spaces. That is called interstitial site. So if this is a crystal lattice, interstitial defect means in any interstitial site, one extra atom or molecule is occupied. Such defects are called interstitial defect. Okay, that is the at the interstitial site you can see an extra atom. Okay, like that. Fine. Now, and in the same way, like vacancy and interstitial defect, you can see in ionic crystals, then the name will change. So it is classified as Schottky defect and Frenkel defect. Okay, which this Frenkel defect. Stoichiometric defects that's seen in ionic crystals. That means ionic crystals means the crystal lattice will contain anions and cations, right? So in that case, what will be the Schottky defect and Frenkel defect? This is important defect. We can explain this in more detail with figure. Okay. So this is an ionic crystal lattice. Okay. So it has both the cations and anions will be arranged like this, right? You can see the arrangement of cations and anions. And in this case, what is called Schottky defect. That is, if one cation is gone, that means there is a deficiency of one cation, right? That means it affects the stoichiometry. The ratio should be same. In order to not affect the stoichiometry, if one cation has gone, at the same time in order to balance an anion also should go. Okay. So such defects where there is a vacancy of anion and cation. Such defects are called Schottky defect. Okay. Then what about Frenkel defect? In the similar way, it is seen in ionic crystals and it is a stoichiometric defect. So what happens in this case? So one more layer we can draw. Cations and anions are arranged like this. In this case, it is similar to interstitial defect. That is, in the interstitial site, we can see one cation. But this cation is not from outside. It is any from the position, exactly occupied position. It will shift to the interstitial site. So this cation is now moved to this interstitial site. So that means there is no change in the ratio of both anion and cation, right? So it does not affect the stoichiometry. So such type of defects where a vacancy is also there, that is a vacancy defect is also there, also an interstitial defect is there. So Frenkel defect is a combination of vacancy defect and as well as interstitial defect. Okay. And an example of Schottky, and one more point you have to remember. In this case, the size of cation and anion, they are almost similar. Okay. And in this case, the size of cation is small when compared to what? Anion. Okay, fine. So these are the stoichiometric defects. Hope it is clear. Next class we can do non-stoichiometric defects. Okay, till then bye.